Hello, average engineers. Today I wanted to talk about something that happened recently in the data engineering community, and I cannot believe more people aren't talking about it. I don't know if people are living under a rock. It's pretty much like somebody landed on the moon of data engineering. Nobody's talking about it. I have no idea why. Either I'm crazy or everyone else is crazy. The thing that's got me so worked up is something called Spark Connect. It was released in Apache Spark 3.4. I'm assuming you know what Apache Spark is. It's the GOAT of the data engineering world right now. It's what powers Databricks. It's the big data tool. Everyone uses PySpark. I mean, Spark, man. I don't know. It's the best tool since sliced bread. It pretty much powers everything. Everybody's learning Spark. It's hot. It's pretty much the go-to tool for crunching data, and it has been for a while. The thing that's crazy about Spark Connect is that we kind of have to step back and talk about Apache Spark at a high level. Spark at a high level is a JVM thingy. It runs on the JVM. This has caused problems for the interoperability of Apache Spark. If you think about this picture I drew here, the big problem with Spark is that it's kind of off in itself in its own little world. It lives on a Spark cluster somewhere. It could be Databricks, could be EMR, somewhere in the cloud. You've got this distributed system set up on a bunch of clusters running Spark. You submit Spark jobs. They crunch a bunch of data and typically pass data back out. Since there is a few tools here and there, you can write a data frame, get it into a Postgres table pretty much. But for the most part, Spark has just been kind of like this awesome tool used by everyone, but it's kind of in its own little world. It has these little walls built around it. It's hard to interact with Spark, especially when you think about other backend tooling, say Golang, Rust, Python running on the back end. These tools really haven't been able to interact well with Spark. And this creates a lot of this creates a lot of walls and problems in data engineering, because you've got all this Spark pipelines crunching all this data, doing all this analytics, pushing out all this awesome stuff. It's the tool, it's the GOAT. But then you have this problem of, what do I do with the analytics it's producing? And a lot of times what happens is that data gets written out of Spark into like a Delta table, into CSVs, into Parquets, into some storage, an S3 bucket. And then you have to write these other backend systems that might, ingest that data into Postgres or into Snowflake or into whatever, right? There's these hop steps, there's these walls built around Spark that you have to do these kind of jumps and hoops to consume things from Spark from these other backend systems to keep the flow of data going. That brings us to Apache Spark Connect. Spark Connect was released with 3.4. I cannot believe more people talking about it. What it does is basically break down these walls built up around Spark. A quote from the website, it's a decoupled client-server architecture that allows remote connectivity to Spark clusters using the DataFrame API. What does that mean? Look at this picture again. It means you've got these backend systems, Golang, Rust, Python, whatever, running anywhere on your laptop on a server. Now we have an API basically to talk to that Spark cluster. You can say, hey, Spark cluster, do this thing, give me this result, run this thing, give me back as an application that result from Spark, which has really been impossible up till now. This is really amazing because it's just another thin API layered over Spark, and now you can write all these back-end data apps, all this other stuff that can just talk to Spark and say, hey, give me this thing, do this thing. And now that wall has kind of been broken down. So now the line has been blurred between the back end and this powerful tool called Spark. So to test this out recently, because this is crazy, what I did is I set up a Spark cluster, a simple one on a Linode. I set up a Linode, a little small cloud instance. I installed Apache Spark on it. I'll show some of that stuff here. I started up the server. I started up the client server. And once I'd done that, it's really important also to set up security when you're doing something like this, because of course, if you're talking about an API that's open to the internet, all of a sudden security is a thing again, right? You can't just have anybody connecting to your Spark Connect and doing whatever they want, obviously. But in my case, what I want to do is I wanted to say, is this really true? Can I really write Rust on my local machine and talk to this remote Spark server that I set up and have it do something? So what I did is on that remote Spark server, I just made a really simple file. You can see it here. Just made a really simple CSV file, and I wanted to see, can I get Rust, a Rust project, to talk to that Spark server and give me the results of that file from my Rust app on my computer? And again, I want to reiterate just the things that the possibilities that this opens up. New tools can be created. People can start new companies. I don't know. It's just amazing. I think it's amazing because Spark is amazing. It's everywhere. It's powerful. It's the most popular and most powerful distributed data processing tool there is out there. And the fact that now there's an API you can remotely connect your code, your backend code, to that Spark server is amazing. I would think people would build all sorts of new tools and new products based on this. I added a couple cargo crates, Tokyo, and then Spark Connect RS. That's the actual package that Rust has out there to talk to this Spark. It's in beta, so not production. You can see my file there. The most amazing part about this is look at the Rust code I wrote. It's just a couple lines. It's Rust. You'd think it'd be complicated. It's not. And if you have written Spark before, PySpark, this is going to look incredibly familiar to you. Look at this. Spark session, connect to that IP address, which is the IP address of my Spark cluster I set up along with this port. That's the port that the Spark Connect runs on. Make that Spark session. I can run some Spark SQL and say select from the CSV that's on this machine. Of course, in the real world, that could be a file in S3, whatever, a Delta Lake table could be whatever. In my tool example, it says my data on that Spark server. I say show me what's in there. I go ahead and build and run that cargo run release, and voila. Spark sends back to my Rust program the results of that CSV file. I mean, that's amazing. It's just amazing to me that more people aren't talking about this. Just the possibilities that it opens up in the future. I don't know. I feel it's like landing on the moon. You could do all sorts of crazy stuff. I mean, I don't know if I'm crazy, if everybody else is crazy. It just seems like you could build a lot of amazing tools. This could change the way a lot of data pipelines are written. You don't have to do these hop, skip, jump things, weird things about, exporting out. And there's just these layers and walls built around Spark where nothing can just talk to Spark because of the JVM. And I realized I had an API before, but now Spark Connect is here. It's a thin API on top of a Spark cluster. You can write Golang, Rust, Python, whatever, attached to that cluster and say, hey, run this thing, give me the results of this, do whatever, and give it back to me. And of course, that can be data apps, can be analytics, whatever. Again, it keeps me asking, is this a new era of ETL and data engineering? It really feels like it. Maybe it's just because I like Spark and I use Spark and I use Databricks a lot, but this just really feels like a big deal because a lot of people use Spark, a lot of people use Databricks. It is a big deal. Golang is popular now. Rust is getting very popular. It's amazing the tools you can build with those, and then your ability to plug in those backend tools directly into a Spark server and run a Spark cluster and run code is just amazing. I think it opens up a ton of opportunity for people.